Waters, and today we're going to learn the last topic in Unit 3, which is fission and fusion. Nuclear fission is when nuclei of certain isotopes are bombarded with neutrons and split into smaller, more stable fragments. It produces a great amount of energy, mostly heat, but less than fusion. Uranium is used as a source. It's used in atomic bombs and nuclear reactors. It uses neutron chain reaction, which means a neutron hits the nuclei, breaks it down to smaller, and 3 neutrons leave that and go to another and hit other nuclei, and they continue on. It does not need high temperatures to occur. It can be controlled in a laboratory, but disposal is difficult and dangerous because it still is radioactive, and so it has to be disposed of very carefully and always remain cool. Okay, and what nuclear fission looks like is if we look at this picture down here. So a neutron hits a nucleus, and the nucleus splits into two and releases 3 neutrons. And those 3 neutrons then head for another nuclei and hits that nucleus and splits it into with 3 more neutrons and so on. Okay, so this is what we use in current nuclear reactors, and this is what we've used in nuclear weapons. Now, nuclear fusion, nuclei combine to produce a larger and more stable nucleus of intermediate size. The increase in stability releases a large amount of energy, which is more than fission. This is used in hydrogen bombs and provides energy in the stars like our sun. It produces little waste compared to fission reactions because it just creates elements that are a little bit bigger, but yet not radioactive. However, the downfall is it occurs at extremely high temperatures. It cannot be controlled in a laboratory yet, but is a major focus of research, and they have been working on it. So this is what happens. So this is the picture of fusion. So we take deuterium, which is a hydrogen with 1 proton and 1 neutron. So 1 proton, 1 neutron. And a tritium, which is got 1 proton and 2 neutrons in its nuclei. And we smush them together. And what we get out is a helium, a neutron, and energy. Lots of it. Okay, so this is what's burning in our sun. It's really not a fire, it's fusion that's going on. Okay, and what I want you to think about when we talk about nuclear fusion and fission is this something that's feasible for to be more of a source of energy than what we currently use with coal? And if we can, what are some downfalls of both nuclear fusion and nuclear fission? And is it something that the US should be looking into? So think about those things. Maybe look up some information on nuclear reactors. Well, anyway, have a great day.